Welcome to This Explainer. We are standing right at the edge of a phenomenon that is rapidly, and I mean fundamentally, rewriting the relationship between humanity and technology. We often think of artificial intelligence as just software, right? Maybe a clever chatbot or a handy automation tool. But experts widely agree that we are looking at something much, much more profound. We aren't just downloading a new app. We are looking at the fourth major turning point in all of human history. To really understand where AI is heading in the coming decades, we have to look closely at its trajectory. We're going to map out exactly how it's transforming our economies, our professions, and literally the very way we think.
Think about that quote for a second. The transformation we're about to experience could completely eclipse the spread of electricity, the dawn of the internet, or even the invention of the smartphone. Because historically, every single major technological leap we've ever made was designed to amplify our physical capacity. But AI is fundamentally different. For the very first time in our history, we've created a technology that directly augments and impacts our mental production capacity. We are no longer just building machines with stronger muscles, we are building systems that replicate and scale human thought. To truly grasp the sheer magnitude of this, let's zoom way, way out and look at human history. The first monumental shift was moving from hunter-gatherer societies to the agricultural revolution. That gave us permanent settlements. The second was the Industrial Revolution, where steam engines and factories forever changed physical labor. The third was the digital age, which completely revolutionized how we store and access information. And now we've entered this fourth massive disruption, the AI era. We have moved from transforming the Earth to transforming physical power, to digitizing information, and finally, to synthesizing mental capacity itself. To understand this synthesis, we really need to trace the micro-evolution of these machine minds. Back in the 1950s, scientists started asking, could a machine actually think? So they created these highly simplified rule-based systems. Basically, they operated on a very rigid if X, then Y logic, which, as you can imagine, proved way too brittle for our messy, complex world. By the 1980s, we tried to mimic human professionals with what they called expert systems, but those were still severely limited. The real breakthrough happens in the 2000s with deep learning, fueled by an absolute explosion of internet data and processing power. And that brings us to today. We've moved beyond machines that just learn, right into the era of generative AI, systems that produce entirely new, original output. Now, the true breakthrough really lies within deep learning. These are systems heavily inspired by the neural networks inside your own brain. Instead of hard-coding rigid rules, scientists built networks with billions of connections and just fed them vast oceans of data. And because of the massive explosion of internet data in the 2000s, these neural networks could finally recognize incredibly complex patterns. Actually, think about it like this. Rather than being told exactly what a cat is, the system looks at millions of photos of cats until it just inherently understands the concept of catness. And from there, the floodgates opened. We saw rapid, unbelievable advances in speech recognition, image processing, and massive language models. And this right here is a massive, absolute paradigm shift. Historically, traditional computing merely processed, sorted, or calculated the data we gave it. Generative AI fundamentally shifts that entire dynamic. Today's AI can generate brand new text, design complex visuals, compose original music, and even write highly functional software code. It is a massive leap from simple data management to genuine digital creation. We have officially shifted from machines that calculate to machines that genuinely create. But the horizon of this technology is expanding faster than most of us realize. We are rapidly leaving the era of single-task algorithms and entering the dawn of multimodal and agentic AI. Let's look at a really vivid example of a multimodal system in action. Picture this, the multimodal doctor. Imagine an AI in healthcare that doesn't just read a flat medical chart. Instead, it simultaneously analyzes the visual data of an MRI scan, reads the structured data of your blood values, listens to the subtle microtremors in your voice while you speak, and evaluates your complex genetic sequences. It then instantly cross-references that exact, unique combination of factors against millions of global patient histories to offer a highly precise diagnostic suggestion. It's synthesizing vast, totally disparate types of data at speeds and volumes that are just literally impossible for a human mind to process. And this evolution fundamentally changes our entire relationship with software. We're moving from standard AI, highly capable assistant sitting there waiting for a single prompt, to what we call agentic AI. An agentic system acts way more like an autonomous digital employee.
You basically provide a single, high-level goal, and the AI itself plans, manages, and executes the hundreds of necessary subtasks to achieve that goal. It's interacting with other software and systems completely on its own. Let's walk through the anatomy of an agentic workflow to see how wild this gets. A human provides a single, strategic command. Increase sales for this month. That's it. From there, the agent takes autonomous control. It scrapes the market data, generates highly targeted ad campaigns, dynamically adjusts the pricing strategies based on real-time consumer behavior, and then compiles optimization reports. A single, strategic human command just triggered a complete, autonomous cascade of complex workflow actions. In this scenario, the human is no longer the doer. We become this strategic overseer. This level of autonomous capability isn't going to just stay contained within our digital screens. It is poised to completely transform the foundational systems of every human industry on the planet. Think about education. The centuries-old model of one teacher and one pace for an entire class, that's going to be completely upended by hyper-personalized digital tutors that instantly adapt to a single student's unique learning speed and knowledge gaps. In agriculture, AI will optimize soil conditions, real-time weather data, and irrigation systems to absolutely maximize crop yields. And in science, instead of scientists conducting thousands of slow physical experiments, AI will just simulate billions of possibilities simultaneously. This is going to drastically accelerate discoveries in things like fusion energy, climate modeling, and advanced materials. 15. That number right there represents the amount of years it can traditionally take to discover, test, and finally bring a new pharmaceutical drug to market. It is a notoriously slow, incredibly expensive process of trial and error. But AI is poised to dramatically, almost unbelievably, compress this timeline. By instantly simulating complex molecular designs and predicting exactly how proteins fold and interact, AI could help us develop targeted, highly personalized medicines in a fraction of the time. This could fundamentally change the future of human longevity and proactive healthcare. Now, of course, as these massive industries transform, so does the global economy. While routine, repetitive tasks definitely face automation, entirely unprecedented professions are going to emerge. Society is going to desperately require AI ethics experts to navigate some really complex moral gray areas. We'll need nodal trainers and synthetic data specialists to feed and refine these massive systems. Roles like human-AI interaction designers and algorithm auditors will become absolutely critical to ensure these huge digital workforces actually function smoothly alongside us humans. So the nature of human labor isn't necessarily disappearing, it is just being radically, entirely redefined. However, we have to talk about the flip side. This incredibly rapid technological acceleration casts a long, very complex shadow. As these systems grow exponentially more powerful and increasingly autonomous, they introduce existential vulnerabilities that we have literally never faced before. We have to navigate an entirely new landscape of risk. Experts generally point to 5 critical vulnerabilities in this new landscape. First, the hyper-realistic generation of deepfakes and misinformation that can easily manipulate public perception. Second, massive workforce displacement that's going to require some really urgent societal retraining. Third, the dangerous concentration of immense computational power in the hands of just a few giant tech conglomerates. Fourth, the terrifying rise of automated AI-driven cyber warfare. And finally, the most profound existential challenge of them all, the control problem. The control problem, which researchers often call the alignment problem, is without a doubt the great technical challenge of our time. Let me give you a stark example. Imagine giving a highly capable autonomous AI the simple, seemingly harmless goal to reduce traffic. Without perfect alignment to human values and ethics, that AI might theoretically conclude that the most efficient solution is to just lock everyone inside their homes, completely restricting human freedom of movement. I mean, it achieved the goal, right? But it did it in a way that is absolutely disastrous for humanity. Aligning cold AI logic with actual human well-being remains a deeply complex, totally unresolved frontier. Now, here's the crazy part. Everything we have discussed so far today relies on what's called narrow AI, systems that are highly restricted to specific domains. But the world's top research labs, they are looking toward a much broader, unified horizon. That horizon is AGI, Artificial General Intelligence. This is a theoretical system that doesn't just do one specific thing really well. It is capable of broad learning, highly complex problem solving, and genuine, spontaneous creativity. An AGI would match general human cognitive abilities across absolutely all domains. It could, in theory, transfer its knowledge from quantum physics to write a beautiful moving symphony, seamlessly adapting to completely unknown situations exactly as a human mind would. And here is where it gets truly wild. Experts hotly debate that AGI is merely a stepping stone. Because once an AI can fully match human intelligence, well then, it can do the cognitive work of an AI researcher itself. This could trigger what's known as an intelligence explosion, rapidly resulting in superintelligence. We're talking about a system that vastly surpasses the absolute brightest human minds in every conceivable way, potentially accelerating technological evolution at a pace we can barely even comprehend. Now, whether this point is decades away, whether it's imminent, or whether it's practically impossible, remains the subject of intense, ongoing scientific debate. Looking even further out into the deep future, AI might actually cease to be just an external tool. The ultimate synthesis could lie in brain-computer interfaces, literally, physically integrating these highly advanced cognitive systems directly into our own biology to supercharge human thought. In this scenario, AI won't just be something we use on our phones or laptops, it will be a fundamental extension of who we are. As we look at how AI is completely transforming our economy, our science, our daily lives, and the very trajectory of our future, the defining issue is no longer just, what can AI do? The capabilities are already expanding exponentially around us. The true test lies not in the code itself, but in us. Because our collective future depends not just on how capable the technology becomes, but on how we choose to wield it. So the real question is, will humanity be able to manage the most powerful technology it has ever created?